figure shows the strain stress curve for a given material. What are Young's modulus and approximate yield strength for this material? Now, a material is being given, and in that material force is applied, and after that the strain and stress relationship is being plotted in a graph like this, where they have taken stress along y-axis and strain along x-axis like this. After application of force, the relationship between stress and strain of the material is being plotted in a graph like this. Our motto is to find the Young's modulus of this material, Y of this material, and then approximate yield strength of this material. Both we need to find approximate yield strength. That is what we are motivated to find in this problem. Young's modulus of the material given and then approximate yield strength. Now let's investigate the quantities given to resolve the problem. Actually, we need to identify the quantities from the given graph. As you can see, the well noticeable value in the point in the graph is this. Actually, the stress value corresponds to 150 and the corresponding strain value is 0.002. So we can take value of stress as 150 into 10 to the power of 6 Newton per meter squared. Why 10 to the power of 6? Because the graph is drawn on the scale of 10 to the power of 6 Newton per meter squared. And then the value of strain can be written as the corresponding value of strain, as you can see from the graph, it is 0.002. There is no unit for strain, so it is simply a value. Next, yield strength. This is for your problem A. Quantities given to solve your problem A, and quantities we have to identify for your problem B. That is yield. Definition of yield strength. Yield strength can be defined as maximum stress sustainable without crossing elastic limit. Without crossing elastic limit. That is defined as your yield strength. So as you can see from the graph, the maximum stress is this point. Approximately it is 300 Newton per meter squared. So the maximum stress identified from the graph can be written as the maximum stress. This is also approximate because we are not reading from the graph, just from the abstract graph given. So approximate maximum stress is equal to 300 into 10 to the power of 6 Newton per meter squared. Now we move on to resolve the problem. As we know already, the formula for Young's modulus Y is equal to stress by strain, which is equal to, what is the value of your stress? 150 into 10 to the power of 6 Newton per meter squared divided by, what is the value of your strain? 0.002, which can be rewritten as 15 into 10 to the power of 7 divided by 2 into 10 to the power of minus 3. If we take the factor of 10 to the top, to the numerator, it will become 15 by 2 into 10 to the power of 10. This will become positive, so it adds up to 7, 10 to the power of 10. The answer is 7.5 into 10 to the power of 10 Newton per meter squared. That is the value of Young's modulus Y. Next, we are moving on to your problem B. Problem B, as we have given the definition earlier, approximate maximum stress is equal to the yield strength. So, the maximum yield strength, so your approximate yield strength is equal to maximum stress, which is equal to, as identified from the graph, 300 into 10 to the power of 6 Newton per meter squared. So the result for your problem A, that is finding the Young's modulus Y is equal to 7.5 into 10 to the power of 10 Newton per meter squared. Likewise, for your problem B, approximate yield strength is equal to maximum stress, which is equal to 300 into 10 to the power of 6 Newton per meter squared.